Hi, my name's Gabe. For this problem, we're asked to find the vertices of the image of this square after we apply a horizontal stretch with k equals 2. So since we want to use a matrix to represent our horizontal stretch, the matrix we'll want to use will be of this form. Where our k value is 2. So we're going to take our k value and plug it into this matrix. So now we want to start finding our vertices after we apply this matrix. So let's begin by just looking at the origin. So at the vertex 0, 0. So what we're going to have is we first want to think about representing this with a column matrix. So we'll represent the point 0, 0 with the matrix 0, 0. Now to find the transformation of this point, we want to multiply this matrix by our transformation matrix, which is given by 2, 0, 0, 1. And we're multiplying this by the matrix 0, 0. So what we see here is this is going to be the column matrix, where the top row is going to be 2 times 0 plus 0 times 0, which is 0. And the second row is going to be given by 0 times 0 plus 1 times 0, which is going to be 0. So after applying the transformation to the point 0, 0, we're back right on top of the point 0, 0. Okay. Next, let's go ahead and let's look at the point 3, 0. So to apply our transformation to this point, let's go ahead and represent this using a column matrix. So our first row will have a 3, and our second row will have a 0. To find the transformation, we'll multiply this by our transformation matrix, which was the matrix 2, 0, 0, 1. And we're multiplying our matrix by that. So what do we have? We have 2 times 3, which is going to be 6, plus 0 times 0 in the first row. And in our second row, we have 0 times 3, plus 1 times 0, which is 0. So this point, 3, 0, after we apply our horizontal stretch, gets moved to the point 6, 0. And as we continue on, let's go ahead and look at the point 3, 3. We'll begin by thinking about this point as a column matrix, where the first entry is 3, and the second entry is also 3. To find the transformation of this point, we'll multiply this matrix by our transformation matrix. And what we'll see here is this is equal to 2 times 3, which is 6, plus 0 times 3. So our first row is 6. And in the second row, we have 0 times 3, which is 0, plus 1 times 3, which is 3. So this point gets translated to the point 6, 3. And finally, we have to look at the point 0, 3. So again, we'll begin by representing this point with a column matrix, with a 0 in the first row, and a 3 in the second row. To find where this point gets translated, we'll multiply our column matrix by our transformation matrix. And now what this gives us, in the first row, we'll have 2 times 0, which is 0, plus 0 times 3, which is 0. So in the first row, we have a 0. And in the second row, we have 0 times 0 plus 1 times 3, which is 3. So this point represents the point 0, 3. So it gets laid right on top of itself. Now to go ahead and sketch the transformation, we'll just connect the 4 points that we found using straight lines. And there we have the transformation of our square after applying a horizontal stretch with k equals 2. Thank you.